Yeah, 'cause it was funny. I was like, these are live because if I was pre-recording these, you would not have that happen. So, today's session is finding the greatest common factor. So I took a lesson from when we were talking about the least common multiple and how we basically spent a whole hour on that. So I figure I'm going to spend a whole hour on just the greatest common factor. I do have a video on 6.1, and I talk about and I go through some of the same examples in 6.1. I've basically taken all the greatest common factor stuff from that video, and then I've pulled it into here and added a lot more examples so that hopefully it makes more sense and there's more examples demonstrating what's going on. So that's sort of, so there, if you've watched that video, there will be some overlap, but there's also going to be new examples as well. So the greatest common factor, we abbreviate GCF. So we need to first talk, we got to pick apart these words here. So we're going to start with factor. So a factor is a number or quantity that when multiplied with another produces a given number or expression. So it sounds confusing. So if I say I have 2 times 3, 2 times 3 gives me 6. So those numbers that multiply to 6 are called factors. So 2 and 3 are factors of 6. So when we are talking about the factors of something, or we're talking about a factor, the factors of a number are numbers that you can divide evenly into it, because 2 and 3 can be divided into 6. So even though a factor is something that's multiplied by another thing, think of it as the opposite, as we're looking for numbers that divide into what we're looking at. The greatest common factor, so that's common, so that has to be in common if you're looking for a group of numbers, just like the least common multiple. It's the greatest, the largest factor that is in common. So when we're looking at the greatest common factor, say we have two numbers like 36 and 42, we're looking for the largest number we can divide into both of those values. So our greatest common factor will be equal to or smaller than the two numbers. So even though it's called the greatest common factor, the fact that we're dividing it out means it has to be a smaller number than what we started with. It's sort of the opposite of the least common multiple. The least common multiple is bigger than what you started with, and yet it has the name least. So the terminology is really confusing. So think we're looking for numbers that divide into a set of numbers, and we're looking for the biggest one we can divide out. It's sort of like when you're reducing a number. I think we talked about greatest common factors a little bit possibly with reducing. You're trying to divide the biggest thing out of it so that you can get it as small as possible. So we're going to start with just looking at the greatest common factor of integers, which are basically whole numbers, positive or negative. There is no there's not really greatest common factor with decimals. You can do it with fractions. It's difficult. We're just going to focus on whole numbers. So there are two different methods you can do. You can do using divisors, where you're literally listing every single number you can divide out of something, and then you're looking for the biggest one that's in common. That works if you have small numbers, but if you are finding the greatest common factor of a really large number, you might be listing a lot of numbers, and so that may not work so well. Your other option is to do prime factorization. So we used the prime factorization when we were looking for the least common multiple. So we'd be using that same technique where you'd have to do prime factorization. And when we did the least common multiple, we were picking all the primes with the highest exponent. For the greatest common factor, it's all the primes with the lowest, the smallest exponent. So it's sort of the opposite of the least common multiple. So it's the same sort of step. You're just picking different groups of numbers. So my first example, we're going to do this both ways so that you can see both ways and you can kind of choose whichever one you like. So we're going to find the greatest common factor between 30 and 42. So we're looking for the largest number that I can divide out of 30 and 42. Those, if you know your multiplication tables, you know your division, you can do that in your head, but we're going to first do this just by using divisors. So using divisors mean you list all of the numbers that you can divide into each of these. And so these are the factors. So factors of, we're going to start with 30. So all of the numbers we can divide into 30. So I can divide 30 by 1 and get a whole number. I can divide 30 by 2 and get a whole number. I can divide 30 by 3 and get a whole number. 30 divided by 4 doesn't get a whole number, but 30 divided by 5 gets me a whole number. And 30 divided by 6 gets me a whole number. Can't divide by 7, can't divide by 8. Can I divide? Nope, can't divide by 9. I can divide it by 10. Let's see, 11. Not 30 divided by 12, that doesn't work. So you're basically just going through all the possible numbers. Let's see, 30 divided by 15 gets me a whole number. And you go all the way up, and then the next one actually would be 30. So this is a list of all of the numbers that divide into 30. So you just write them all up. These are all factors of 30. And they generally come in pairs, because if you go from the first number to the last number, 1 times 30 is 30. Move 1 in, 2 times 15 is 30. 3 times 10 is 30. 5 times 6 is 30. So they come in pairs, and then you just write them all out. Then you want to do the same for 42. So you're writing all the factors of 42. And you're going to start from 1 and then go all the way up to 42. So you have 1, 2, and this is where your calculator comes in handy. You just keep dividing to see what comes out to a whole number. So 42 divided by 3 does come out. Not 42 divided by 4, not 5. We've got 6. We've got 7. Not 8, not 9, not 10, 11, let's see if 12, nope, 42 divided by 13, nope, 42 divided by 14, okay, so you have 14, let's see, 15, the next one's going to be 21, and I'm doing this because I'm using the pairs, and then 42. So where you start thinking of pairs is sort of the halfway point. When you get two numbers that are like really close to each other here. Because 5 times 6 gives you 30. So then the first 4 numbers here have to match the last 4 numbers. So 6 times 7 is 42. So then I have to 14 times 3. So these kind of match together. 2 times 21 gets me 42. 1 times 42 is 42. So they're all paired up. So that helps me narrow down, because otherwise I don't want to sit on my calculator and literally divide 42 by 42 different numbers. That is very time consuming. So you write down all of the factors, all the numbers that divide into 30, all the numbers that divide into 42, and then the greatest common factor is the biggest one they have in common. So they both have 1, 2, 3, and 6 in common, but the biggest one that they have in both of the lists is 6. So that makes the greatest, let me do blue, not blue, black. That makes the greatest common factor equal to 6. So 6 is the biggest number you can divide into 30 and 42. So that's the method of using divisors, basically writing all of the different choices. The next method is prime factorization. So I'm going to be making my factor tree. So I'm going to start with 30. And 30 is 5 times 6. 5 is prime. And then 6 is, oh my goodness, I don't know what my pen is doing. 6 is 2 times 3, and 2 and 3 are prime. Then I'm going to make a factor tree to 42. So 42 is 6 times 7. 7 is a prime number. And then 6 is 2 times 3. So I'm going to write my prime factorization for each. So 30 is 2 times 3 times 5. And then 42 is 2 times 3, and then times 7. Now, when I was doing the least common multiple, anything that was written down came with the multiple. Here, I'm only picking what's in common. And then if they have different exponents, I would have to pick the smallest exponent. But the only things they have in common are the 2 and the 3. So 2 times 3 gives me 6, so that means the greatest common factor is 6. So we get the same answer. One, by listing all the possible numbers and then looking for the biggest one that's in common. The second method by doing the prime factorization. Do you guys have questions on this example? Okay. I'm going to do another one where I'm doing both methods. So we want to find the greatest common factor between 54 and 78. So we're going to do it with the divisor method and then using prime factorization. So let's start with using divisors where I write down all the possible numbers that multiply to 54. So instead of doing it like I did on the previous slide where I put them horizontal, I could do them vertically. So factors of 54. So I know that 1 divides into 54 and 54 divides into 54 because 1 times 54 is 54. 54 is even, so I know 2 goes into 54, and 54 divided by 2 comes out to 27, so that's my next choice. So then I try 54 divided by 3, so that's a whole number, and 54 divided by 3 gets me 18. Let's see, I can't do 54 divided by 4, it doesn't divide by 5. 54 divided by 6, so that's 6. 54 divided by 6 gets me 9. And then 54 divided by 7, and 54 divided by 8. And then if I do 54 divided by 9, that's already on my list, so now I've started repeating my list. So these are all the possible numbers. These are all numbers that divide into 54. I've just written them in their pairs to help you see how they kind of go together. Then I'm going to do the same thing for 78. I'm going to write these in pairs. So you always start with 1 and then the other number. 1 times 78 gives me 78. So 78 is divisible by 2. So 78 divided by 2 gives me 39. So that's the next pair. 78 divided by 3, that comes out to a whole number. So 78 divided by 3 gives me 26. So that's the next pair. 78 divided by 4 is a fraction. 78 divided by 5 is also 78 divided by 6. Okay. 6 and 13. 78 divided by 6 is 13. 78 divided by 7, that's a decimal. 78 divided by 8, that's a decimal. 78 divided by 9 is a decimal. 78 divided by 10 is a decimal. 78 divided by 11 is a decimal. 78 divided by 12 is a decimal. And then I'd be up to 13, which I already have the list, so that's where I could stop. So now we look for the biggest number that's in common. And it looks like it's 6 yet again. So 6 is the biggest number that they have in common. That just, I picked these numbers kind of on, actually used a random number generator to pick these numbers. So that means our greatest common factor is equal to 6. So 6 is the biggest number that I can divide out of 54 and 78. So it has to be able to go into both. So now let's do the prime factorization method. So I'm going to do my factor trees. So I'm going to have 54, which I know that 9 goes into 54. That's 9 times 6. 9 is 3 times 3. 6 is, oh my goodness, my pen's being weird again. 6 is 2 times 3. And those are all prime numbers. So 54 is 2. And then I have 3 3s there, so I can write that as 3 to the third power. Then 78, I know that's even. That comes 2 times 39. 2 is a prime number. And I know that 39 can be divided by 13 and 3. And 13 and 3 are both prime numbers. So 78, I can write underneath here 2 times 3 times 13. So when you're using the prime factorization, you want the smallest exponent when you're comparing these. So if I'm looking down, they both have a single 2 in common. The next one, there's a 3 to the third and then a 3. The smallest exponent would be just a regular 3 without any exponent at all. They have a single 3 in common, but they don't have more than one in common. One of them has 3 3s, but one of them only has 1. So they only have a single 3 in common between them. And then the 13, one has a 13, one doesn't. So it has to be what do they have in common. So they only have 2 times 3 in common, which again gets us our 6. Are there any questions? Which method do you prefer out of these two methods? Which one do you think is easier or makes more sense? You can go ahead and type it in the chat box. I'm wondering if there are some delays. On Blackboard there might be some delays here. Well, I don't see I don't see a response to my question on which one you prefer. So you can tell me later. If you're watching the recording, you can email me. I'm curious. Okay, so now example 3 is finding the GCF between 24, 40, and 8. So now we're looking at the greatest common factor between 3 numbers. So whenever I'm doing this, I always look at the smallest number because I have to be able to divide a number out of all 3 of these. And so I look at the smallest number and I choose the factors of the smallest number, and then I see which of those go into both of the numbers. So out of these 3 numbers, 8 is the smallest. So I'm going to write down all the factors of 8. And these are just all the numbers that multiply to 8. So that's 1, or that divide evenly into 8. There's not a lot of them. It's 1, 2, 4, and 8. So there's only 4 numbers you can divide into 8. And then I start with the biggest one, and then I ask, does that divide into the other 2? So 24, can I divide that by 8? Yes. 24 divided by 8 is 3. And then I say, oh, 40, can I divide that by 8? Why, yes, that comes out to 5. So if the biggest number out of my choice, based off, oops, not black. So I take the smallest, find the factors, and the biggest one that goes into both numbers, that's my GCF. So in this case, the GCF would be 8, because that's the biggest number that I can divide into all 3 of these numbers. It goes into 24, 40, and 8. So that's an alternate method, is instead of writing down all of the factors, just start with the smallest one and then check those. It kind of saves you some time there. I have another example here. These are larger. We have the GCF between 42, 30, and 60. So I'm going to do the same method here with all 3 of these. I'm going to start with the smallest out of those 3 numbers, which is 30. And then I'm going to write down all the factors of 30. So that's 1 and 30, because 1 times 30 is 30. 2 and 15. 3 and 10. 5 and 6. So those are all factors of 30. And then I'm going to start with the largest one. So if I could write these all in order, 1, 2, 3, 5, 6, 10, 15, 30. So I'm just writing them in order, and then I'm going to choose the lowest one. And I'm going to see, can I divide that into each of my other choices? So 60 divided by 30, that comes out to a whole number, that comes out to 2. But 42 divided by 30, that gives me a decimal. So 30 is not my greatest common factor. So I could just kind of cross that out. So then I would try the next one. I would try 15. Okay, so 60 divided by 15, that comes out to 4. Can I do 42 divided by 15? And that is a no. 42 does not divide into 15, or I can't divide 15 into 42. So that is another X. That's not, doesn't come out to a whole number, so it's not my greatest common factor. So then you try the next one. You try 10. So, okay, 60 divided by 10, that gives me 6. But 42 divided by 10, that gives me a decimal. It gives me 4.2. I'm looking at only whole numbers, so that means my greatest common factor can't be 10. So you're just kind of working yourself down. So the next number to try is 6. So then I try, okay, 60 divided by 6, well, that comes out to 10. 42 divided by 6, well, this comes out to 7. So that is the biggest number in common here that divides into 60 and 42. And we already know it also divides into 30 because we're only choosing numbers that divide into 30. So that means our greatest common factor is, once again, 6. 6 is very common here. Again, I chose these numbers at random. I used a random number generator. Apparently 6 is very common. 6 is the biggest number that divides into 42, 30, and 60. And so this was just an alternate way to find that greatest common factor. Next time I teach this, I'm going to have to try different numbers. The random number generator is failing me. It's giving me the same answer every time. Do you guys have any questions? Okay. So now let's talk about the greatest common factor when you have variables. And I don't think we've talked about this with variables for the least common multiple. So this is something new, is dealing with this when you have variables. So when you have expressions that have variables, so you have letters in them, you're always going to pick the variable with the smallest exponent. So it's very similar to the prime factorization method where you pick the one with the smallest exponent. So it's the same rule for the numbers as it is for the variables. You want the smallest exponent. When you have a binomial expression, which means that you have things in parentheses, and they're binomials, so they have two terms, you look at that parentheses as a grouping, and you still pick the one with the smallest exponent. So we're going to follow that rule. I have several examples. So starting off with just the two rules that you're picking the smallest exponent. So if you're finding the greatest common factor here between x to the third and x to the fifth, the smallest exponent is x to the third, so that's your greatest common factor. It's actually less work than dealing with numbers. That's one way why I kind of love algebra, is actually sometimes when you start using letters, it's a lot easier than when you're dealing with numbers. Now, the second example here, I have x plus 3 cubed. So inside the parentheses is a binomial expression. It has two terms, x and 3. So it's cubed, and then we have x plus 3 squared. So we have the same thing underneath the exponents, and so we're looking for the smallest exponent for the greatest common factor, and that would be x plus 3 squared. Because 2 is smaller than 3 is the exponent. And that's it. That's your GCF. So let's throw in some numbers and letters, because that's where you're mostly going to see them. You're going to see both numbers and the letters. The letters are super easy. It's just a matter, the numbers are the hardest part. So on the left, I have 3xy and 7y. So you're going to work on these in pieces, but so you're going to look at the numbers, then you're going to look at each letter separately. So first, I'm going to find the greatest common factor between 3 and 7. So it's the biggest number I can divide out of 3 and 7. Now 3 and 7 are both prime numbers, which means I can only divide them by 1. So the biggest number I can divide out of both of those is 1, so I'm going to write it down. Then I'm going to go to the variables, and I have an x, and then I have something without an x. So I'm looking for the biggest thing in common. Because I don't have an x in the second term, I can't factor, x is not part of a factor. It doesn't exist, so I can't divide it out. So x is not present in my GCF because it's not present in both terms, or both examples here, or parts. So then I move on to the y's. I have a y in the 3xy, and I have a y in the 7y. So that means they both have a y in common, so I can divide out a y. So my GCF is 1y. And I'd be able to divide that out. Now, there's a lot more space on the second one because it's going to involve a lot more work. So first, we're going to look at the numbers, 12 and 16. So these are small enough numbers that you can usually in your head figure out what the biggest number is that divides into 12 and 16. And I'm going to just GCF of 12 and 16. So the biggest number I can divide out of 12 and 16 is 4. Because 6 divides into 12 but not 16. 8 divides into 16 but not 12. So 4 is the biggest number that divides into both 12 and 16. So I'm going to have 4 in my GCF. And if you wanted to, you could do the prime factorization. You can use any of the other methods to figure out that it's 4. But with small numbers, I usually just use that I know my multiplication and division. Now I'm going to go to the first letter that we have, which is w. So I have a w cubed and a w squared. So I'm going to pick the smallest exponent when they have things in common. So that would be w squared. And then I have a z and a z. So since the z is the same in both of them, they have a z in common. So that makes my greatest common factor 4w squared z. Are there any questions? Okay. Next one. So these are getting a little more complicated. So on the left, we have 15r squared s squared t to the fifth and 5r cubed s to the fourth t cubed. So again, I'm going to start with the numbers. And so I'm looking for the GCF of 15 and 5. The biggest number I can divide out of both 15 and 5. Well, the biggest number I can divide out of 5 is 5. And that also goes into 15. So our GCF is 5. Now I'm going to go to the letters. So I have r squared and r cubed. We want the smallest exponent, so that's r squared. Then the letter s. S squared s to the fourth. You want the smallest exponent, so that is s squared. Go to t. I have a t to the fifth and t to the third. So the smallest exponent would be the 3, so that's t to the third. And once you've gone through all of your variables, that is your greatest common factor. Now, example on the right, this is where we have binomial factors. I have 2a minus b, and then 3 times 2a minus b. So let's put a 1 so that you can see that let me put that in a different color, not black. It does not show up. There, I'm going to write a 1 there so that we can see kind of what we're comparing. So we're looking at these in pieces. So we're looking for the GCF of 1, which is that was not in front of the parentheses, but would be assumed is there, and 3. So the biggest number I can divide out of both 1 and 3 is 1. So I'm going to have a 1 in my GCF. Now I'm going to be looking at the binomial factors, the things that are grouped in parentheses. I have a 2a minus b and a 2a minus b. So in common is a 2a minus b. So that is in my greatest common factor. And so we've gone through everything now that's in those two expressions. So your greatest common factor is 1 times 2a minus b, or you could leave off that initial 1 and it's just 2a minus b. Any questions on either of these two? Okay. Now these are my last two examples here. I have on the left negative 2 wxy and negative 4 xyz. When we're finding the greatest common factor and there's a negative involved, we will always put a negative in our greatest common factor. And this is because when we factor, when you go on to 6.2 and start factoring, it actually makes your factoring a lot easier. So as a rule, we always have a negative if one of our things has a negative. So, and I'm going to look for the GCF out of 2 and 4. So the largest number I can divide into both 2 and 4 is 2. So I'm going to start with a negative 2 for my GCF. Now I'm going to go with my letters. So I have a W, and then I don't have a W. So I can't, they don't have a W in common, so I can't write it down. I have an X and an X in both of them, so I can put an X in my GCF. They both have a y, so I can put a y in my GCF. Now my first group or first expression, negative 2wxy, does not have a z, and the second one does. So because the first one doesn't have a z, they don't have it in common, so I can't write that. So my GCF is negative 2xy. Now I'm going to move to the one on the right. I have 2c cubed times 2c minus 5. And actually, this is a typo. This is supposed to be 3c minus 5 because it's supposed to match the other 3c minus 5. Let me... 2 and 3 are right... Oh, that's a terrible 3. Right next to each other on the keyboard. Maybe I can do that in orange. I will correct this before I upload the PowerPoint. Oh, that's terrible. 3. There we go. I'll just write the 3 there. So those are supposed to match. I did that on purpose. Okay. So I'm looking at the numbers, the GCF in 2 and 4. So we already know that's 2. So I'm going to have 2. Now I'm going to look at my c. I have a c cubed and a c. So the smallest exponent would be on the thing with the c because it doesn't have an exponent at all. So I'm just writing it down as c. And then they both have in common this thing in parentheses, not 3s, 3c minus 5. So since they both have that, that is part of the GCF. So that gives us as our GCF 2c, and then in parentheses, 3c minus 5. Are there any questions? All right. Well, I don't see any questions. You guys got really quiet in the beginning. You were talking. Well, hopefully this makes sense. You need to factor out the GCF when you start factoring, especially because 6.1, half of 6.1 is all about factoring out the GCF. So hopefully having a whole session on the GCF will make that part make more sense, because it's one of the most common things you have to do. You have to do it all the time in algebra. If you have to go on to college algebra or higher level math classes, you will be factoring out the GCF a lot. So this is a very important skill because that pops up. So if you guys have questions, you know how to contact me. And hopefully the rest of my videos in the classroom are helpful. And I will let you know when the next session is. So you guys have a great night. All right. Bye.